And now in this lecture we'll find out the maximum area of a rectangle that is inside the triangle. In the drawing we have triangle ABC. Side AB of this triangle ABC equals to 10 units in its length, side AC equals to 17 units in its length, side BC equals to 21 units in its length. Inside this triangle ABC we have this rectangle PQST. And our mission is to find out the maximum area of this rectangle PQST. So in the first step we will do a construction, that is to say from point A we will do perpendicular on PQ. Again from point A we will do perpendicular on PQ. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and PQ. This point is point M. In the next step, we'll extend the perpendicular AM by straight line until it touches side TS. Again, we extend the perpendicular AM by straight line until it touches line 7 TS. And we define the touching point of the extended perpendicular AM and line 7 TS. This point is point M. Those two angles are defined as corresponding angles and they are located between the parallel lines PQ and TS. Why PQ is parallel to TS? Because of the fact that it is given as the question that for the other PQST is a rectangle, and we know that the opposite sides of a rectangle are parallel to each other. Therefore, in rectangle PQST, side PQ is parallel to the opposite side TS. So those two angles are located between the two parallel lines PQ and TS, and therefore they are equal to each other. But this angle equals to 90 degrees, therefore this angle must be also equal to 90 degrees in its size. Likewise, those two angles are also defined as corresponding angles, and they are also located between the same parallel lines PQ and TS, and therefore they are equal to each other. So, but this angle equals to 90 degrees, therefore this angle must be also equal to 90 degrees in its size. In the next step, I'll copy this right angle triangle ABN in a new page, and we will implement the Pythagoras theorem on this right angle triangle ABN. But before that, we will define the length of this line segment BN or side BN as X. BN equals to X according to our definition. So what is the length of NC? What is the length of line segment NC? From the drawing it is very easy to see that NC equals to BC minus BN. Again, BC minus BN equals to NC. So write it down. NC equals to BC minus BN. So NC equals to BC, that is 21 units, according to what is given us the question, minus BN. BN equals to X, according to our definition. So in total, NC equals to 21 minus X. This line segment NC equals to 21 minus X units in its length. So in the next step, I'll copy this right angle triangle A and C in a new page. I'll copy this right angle triangle A and B in a new page, and we'll implement the Pythagoras theorem on this right angle triangle A and B. The hypotenuse AB of the right triangle A and B equals to 10 units in its length according to what is given us the question. AN is unknown, and according to our definition, side BN of the right triangle ABN equals to X units. Here by PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle ABN that I copied from the original drawing. Again, the hypotenuse AB equals to 10 units and BN equals to X units according to our definition. So, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle ABN is AB, therefore the square of the hypotenuse is AB square, and it is equals to BN square plus AN square. Here we subtract BN square from this equation. Equation 1. And you get according to this equation, equation 1. AN square equals to AB square minus BN square. Okay, again, according to equation 1, we shall find out that AN square equals to AB square minus BN square. So AN square equals to AB square. AB is 10, therefore AB square is 10 squared, that is 100. Minus BN square. BN is X, therefore BN square is X squared. So in conclusion, we should find out that according to equation 1, AN square equals to 100 minus X squared. In the next step, I'll copy this right triangle A and C in a new page, and we'll implement the Pythagoras theorem in this right triangle A and C. Here, side AN is the missing side. Side NC equals to 21 minus X units in its length. And the hypotenuse AC of the right triangle ANC equals to 17 units in its length according to what is given us the question. Again, here by PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle ANC that are going from the original drawing. In this right triangle ANC, according to the Pythagoras theorem, this will be equation 2. According to the Pythagoras theorem, in this right triangle ANC, AC square equals to NC square plus AN square. Here we subtract NC square from this equation, and finally get that according to this equation, equation 2, AN square equals to AC square minus NC square. So according to equation 2, AN square equals to AC square. AC is 17, therefore AC square is 17 squared, that is 289 minus NC square. NC is 21 minus X, therefore NC square is 21 minus X square. So actually, according to equation 2, we found out that an squared equals to 289 minus 21 minus x squared. So, repeat again, according to equation 2, actually found out that an squared equals to 289 minus 21 minus x squared. This is according to equation 2. And according to equation 1, we already found out that an squared equals to 100 minus x squared. So we have here two different equations for an squared. Therefore, we get equation 3 that states that an squared, according to equation 1, must be equal to an squared according to equation 2. So an squared according to equation 1 equals to 100 minus x squared, and it must be equal to an squared according to equation 2. An squared according to equation 2 equals to 289 minus 21 minus x squared. So according to equation 3, we actually found out that 100 minus x squared equals to 289 minus 21 minus x squared. So here we open the brackets of this expression and we get that according to this equation 3, 100 minus x squared equals to 289. We have minus, and here 21 minus x squared equals to 21 squared, that is 441, plus x squared minus 2 times 21 is 42 times x. So in total minus 42x. So according to equation 2, we actually found out that, according to this equation 3, we actually found out that 100 minus x squared equals to 289. And we have minus, inside the brackets we have 441 plus x squared minus 42x. Here we'll open the brackets of this expression and get that according to this equation 3, 100 minus x squared equals to 289. And we have here minus, we open the bracket, so it will be minus, after we open the brackets, this will be equal to minus 441. Here we have minus x squared, minus times minus is plus, so it will be plus 42x. So here we have minus x squared on both sides of this equation 3, therefore minus x squared will get cancelled. After we cancel minus x squared from both sides of this equation 3, in this side of this equation 3 we left only with 100, that equals to 289 minus 441 plus 42x. So here we'll add 441 to this equation 3, and we get that according to this equation 3, we have 100 plus 441 equals to 541. So 541 equals to 289 plus 42x. Here we subtract 289 from this equation 3, and we get that according to this equation 3, we have here 541 minus 289 is equals to 252. So in this side of the equation we left only with 252. In the other side of the equation we left only with 42. So according to equation 42x of course. So according to equation 3 we should find out that 252 equals to 42x. Here we divide this equation 3 by 42, and finally we get that according to this equation 3, x equals to 252 over 42 is 6. So x equals to 6 units in its length. So actually, line segment BN is equal to x is equals to 6. And here we have line segment NC equals to 21 minus x, and x is 6, therefore it is 21 minus 6, that is 15. Okay. We return to equation 1. According to equation 1, we actually found out that AN squared according to equation 1, we have already found out that AN squared equals to 100 minus x squared. And we just right now found out that x equals to 6. X equals to 6. So we substitute x by 6 in this equation 1, we get that AN squared equals to 100 minus x squared. X is 6, therefore x squared is 36. So total AN squared equals to 100 minus 36, that is 64. So AN squared equals to 64. According to equation 1, AN squared equals to 64. Here we take a root out of this equation, and finally we get that according to this equation 1, AN equals to the square root of 64, that is 8. So AN equals to 8 units in its length. So actually we found out that this line segment AN equals to 8 units in its length. So I write it here, AN equals to 8 units in its length. In the next step, we will define the width QS of this rectangle PQST as B. QS equals to B according to our definition. And we will define the length QP of this rectangle PQST as A. So here the length PQ equals to A units in its length according to our definition. So according to what is given as the equation, PQST is a rectangle, and we know that all the angles inside any rectangle are right angles. So this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size in this rectangle PQST. So in the next step we'll focus on this quadrilateral MPSQ. Inside this quadrilateral MPSQ we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore this fourth missing angle must be equal to 90 degrees in its size. So inside the small quadrilateral MQSN we have 4 right angles, and according to rule 6, any quadrilateral that has 4 right angles must meet this rectangle flat as square. So we relate to this quadrilateral MQSN as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle MQSN, side QS must be equal to the opposite side MN. but QS equals to B according to our definition. Therefore, MN must be also equal to B. What is the length of this 97 AM? From the domain, it is very easy to see that AM equals to AN minus NM, or AN equals to AM equals to AN minus MN. N equals to AN minus MN. So AM equals to AN, that is 8, minus MN, that is B. So in total, AM equals to 8 minus B. AM equals to 8 minus B. So write it down here. This is 7 AM. AM equals to 8 minus B. In the next step, we'll focus on those two angles. Those two angles, they are defined as corresponding angles, and they are located between the parallel lines PQ and BC. And therefore, they are equal to each other according to the rule that corresponding angles between parallel lines are equal to each other. So if this angle is alpha, then this angle must be also equal to alpha because they are equal to each other. Likewise, we focus on those two angles. Those two angles are defined as corresponding angles, and they are located between the same parallel lines QP and CB, and therefore they are equal to each other according to the same rule. So if we define the sine of this angle as beta, then this angle must be also equal to beta because they are equal to each other. In the next step, we'll prove that the big triangle ABC is similar to this small triangle APQ. Repeat again. We prove that the big triangle ABC is similar to this small triangle APQ. According to the rule that in a similar triangles, the ratio between the sides is equals to the ratio between the sides. Again, in the similar triangles, the ratio between the sides is equals to the ratio between the sides. Therefore, in these two similar triangles, that is to say, the small triangle APQ and the big triangle ABC, the ratio between the sides is the height AM of the small triangle over the height AN of the big triangle. This is actually AM over AN. So the ratio between the heights of those two similar triangles must be equal to the ratio between the sides of those two similar triangles. And the ratio between the sides is side PQ of the small triangle over side BC of the big triangle. PQ over BC. So it will actually found out, but because of the fact that the big triangle ABC is similar, this is the sign of similar to the small triangle APQ, according to angle similarity rule, the following equation is true. That is to say, the ratio between the heights of those two similar triangles must be equal to the ratio between their sides. That is to say, AM over AN equals to PQ over BC. So here we have AM equals to 8 minus B. So we substitute AM by 8 minus B over AN. AN equals to 8. AN equals to 8. We substitute AN by 8 and it is equals to PQ. PQ equals to A according to our definition. PQ is the length of rectangle PQST and is equal to A according to our definition. So we substitute PQ by A over BC. BC equals to 21 units in its length according to what is given in the question. So we substitute BC by 21. In conclusion, we found out that eight minus b over 8 equals to a over 21. Here we cross multiply this equation and we get that 8a equals to 21 times 8 minus b. So here we divide this equation by 8 and finally we get that according to this equation, this will be equation 1. According to this equation 1, a equals to 21 over 8 times 8 minus b. This is according to equation 1. The next step we'll open the brackets in this side of this equation 1 and we get that according to this equation 1, a equals to, here we have 21 times 8 over 8 is 21 and here we have 21 over 8 times minus b equals to minus 21 over 8 times b. So according to equation 1, we actually found out that a equals to 21 minus 21 over 8 b. Repeat again. According to equation 1, we actually found out that a equals to 21 minus 21 over 8 times b. A is the length of this rectangle PQST. So we multiply this equation 1 by b. B is the width of this rectangle PQST. So we multiply this equation 1 by b. So in this side of this equation 1 we will have a times b. That is to say the length times the width, and we know that the length times the width is equals to the area of this rectangle PQST. Again, a times b equals to the area of this rectangle PQST. That is the area that we are looking for. So in this side of the equation 1 we have a times b, that is the area of rectangle PQST. Here we have to multiply this side of this equation 1 by b. So 21 times b is 21b. And we have here minus 28 over 8 times b is minus 21 over 8 times b is minus 21 over 8 b squared. So actually found out that according to equation 1, a times b equals to 21 minus 21 over 8 b squared. That is to say, the area of this rectangle PQST, that is actually AB, is equals to 21 minus 21 over 8 times b squared. So the area is the dependent variable and is equals to 21 minus 21 over 8 times b squared. B is the width of this rectangle PQST and it is the independent variable because we have to put, we have the right to put to substitute the width b by any positive number, and by choosing the width, the value of b, the area of this rectangle PQST will be determined by this equation. So b is the independent variable in this function and the area is the dependent variable. But our mission in this question is to find out the maximum area of this rectangle PQST. Or in other words, our mission is to find out the maximum value of this function, that is the area function of this rectangle PQST. So in order to find out the maximum value, that is the maximum area of this rectangle PQST, that is actually A times B, we will have to differentiate this function, that is the function area of this rectangle PQST, and after we differentiate the function area of this rectangle PQST, we will equate the derivative to 0, and in this way we'll find out the extreme points of this rectangle PQST. The extreme point must be a minimum extreme point, or it must be a maximum extreme point. We are looking for the maximum extreme point of this rectangle PQST. So in the first step, we'll differentiate the function area of this rectangle PQST. The area equals to A times B. So we take the derivative of the function 20. Here we multiply this equation by b. Therefore 21 times b is 21b, and 21 minus 21 over 8 times b is 21 over 8 b squared. So therefore in total the function area of this rectangle PQST equals to AB, that is equal to 21 times b minus 21 over 8 times b squared. So in the next step we differentiate the function area of this rectangle PQST. So it will be the derivative of 21b minus 21 over 8 b squared. And we differentiate it according to the variable b. And then we'll equate the derivative of this function area to 0. In this way we'll find out the extreme point of this rectangle PQST. The extreme point might be a minimum extreme point, or it might be a maximum extreme point. We will choose, of course, the maximum extreme point of this function area A times b is equal to 21b minus 21 over 8 times b squared. So we have here the derivative of function 21b minus 21 over 8 b squared according to the variable b. So what is the derivative of 21b? The derivative of 21b according to the variable b is equal to, of course, to 21. And what is the derivative of minus 21 over 8 times b squared? It is equal to minus 21 over 8, and the derivative of b squared is, of course, equals to 2b. And the derivative must be equal to 0 in order to find out the extreme points of this rectangle PQST. The next step, we take 21 a second factor out of these expressions. So what is left from 21 from 21 a second factor? What is left is actually 1. Here we have the expression minus 21 over 8 times 2b. So what is left from this expression after we took from it 21 as a common factor? What is left is actually minus 2b over 8 is equal to 0. Here we divide this equation by 21. This is equation 2. Okay. And here we get that 21 over 21 is 1. So here in this side of the equation we left with only 1 minus 2b over 8 because 21 was cancelled. And the other side of the equation we have 0. 0 over 21 is 0. So in conclusion we actually found out that according to this equation, equation 2, one minus 2b over 8 equals to 0. Here we will add 2b over 8 to this equation, equation 2, and we found out that according to this equation, equation 2, 1 equals to 2b over 8. So here we divide both the numerator and the denominator of this expression by 2, and you get that according to this equation, equation 2, 1 equals to 2b over 2 is b, and 8 over 2 is 4. So in conclusion, according to equation 2, we found out that 1 equals to b over 4. We will multiply this equation, equation 2 by 4, and finally we get that according to this equation 2, b equals to 4 units in its length. That is to say, the width b of this rectangle PQST is equals to 4 units in its length. So in other words, when the width b equals to 4 units in its length, in this function area we have extreme point. This function area, that's actually the area of this rectangle PQST, we will have extreme point. So now we have to verify that the extreme point, that is b, is equal to 4. It is indeed a maximum extreme point and not a minimum extreme point, but because of the fact that we are interested on the maximum area of this rectangle PQST. In order to verify that when b equals to 4, we will get the maximum area. It is actually a maximum extreme point, on not minimum extreme point. Actually draw the function area of this rectangle PQST. I draw the function a b, this is the area, this is equals to 21b minus 21 over 8 times b squared. So actually this is the function area of this rectangle PQST. This is the graph of the function area of this rectangle PQST. In the y-axis we have the area, and in x-axis we have the width, that is b. So from the drawing, from the graph of this function area of this rectangle PQST, you can see that when b equals to 4, b is the axis, x-axis, and when b equals to 4, then the value of the area is its maximum value. Therefore, we actually found out that b is equal to 4 units in its length. It is a maximum extreme point and not a minimum extreme point, and therefore that's actually the answer to the question. That is to say, when the width of this rectangle PQST is equals to 4, that is to say when b equals to 4 units in its length, then we get the maximum area of this rectangle PQST. Actually, we can find out the area of this rectangle ABC, rectangle PQST when b equals to 4 from this graph itself. You can see that when b equals to 4, then the area equals to, it is more than 40. Okay, so we can find out the area from this graph, but we'll find out what is the maximum area of this rectangle PQST from the function area itself. And again, the function area of this rectangle PQST, that is to say, the area that is the width times the length, that is 8 times b. the area that is A times B is equals to 21B minus 21 over 8 times B squared. And we already found out that the maximum value of this function area is when B equals to 4. I repeat again, when the width B, you can see in the graph that when the width B equals to 4 units in its length, then the area is its maximum value. Is its maximum value. It is actually above 40 square units. So the maximum area of rectangle PQST is when B equals to 4. Therefore, we substitute B by 4 this function area, and we get the maximum area of this rectangle PQST. Why? Because A times B is the area. So A times B, that is the area of this rectangle PQST, equals to 21 times B. And B, when the area of this rectangle PQST is its maximum value, B equals to 4. Therefore, we substitute B by 4. So it is 21 times B, and B is 4, minus 21 over 8 times B squared. B is 4, therefore B squared is 4 squared, that is 16. So the maximum area of this rectangle PQST will be equal to 21 times 4, that is 84, minus, here we have 16 over 8 is 2, and 2 times minus 21 is minus 42. So the maximum area of this rectangle PQST equals to 84 minus 42, that is 42. So we shall find out that the maximum area of rectangle PQST is equals to 42 square units, and when the area of this rectangle PQST is equals to 42 square units, then the width of the rectangle B equals to 4 units, and the height, that is the length, that is A, is equals to 10.5 units. The height, that is the length, that is 10.5 units times the width, the length, that is 10.5 units times the width, that is 4. So 10.5 times 4 equals indeed to 42 square units. That is the maximum area of this rectangle PQST. Okay, so in the next step I will summarize the lecture. In this lecture, we found out the maximum area of this rectangle PQST that is located inside this triangle ABC. So, in the drawing we have triangle ABC. This is triangle ABC. Side AB of this triangle ABC equals to 10 units in length. Side AC equals to 17 units in length. And side BC equals to 21 units in length. Repeat again, that our mission is to find out the area of this rectangle PQST that is located inside this triangle ABC. So in the first step, we did a construction, that is to say, from point A we draw perpendicular on PQ. Again, from point A we draw perpendicular on PQ. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and side PQ as M. In the next step, we extended the perpendicular AM by straight line until it touches line 70S. And we find the touching point of the extended perpendicular AM with line 70S, this point SN. By doing this construction, we can deduce those two angles are defined as corresponding angles, and because of the fact that those two corresponding angles are located between the parallel lines PQ and TS, they are equal to each other. Why PQ is parallel to TS? PQ is parallel to TS because of the fact that it is given us the question that PQST is a rectangle, and you know that the opposite sides of a rectangle are parallel to each other. So in rectangle PQST, side PQ is parallel to side TS. So those two angles are located between the parallel lines PQ and TS, and therefore they are equal to each other. But this angle equals to 90 degrees according to our construction. Therefore this angle must be also equal to 90 degrees because those two angles are equal to each other according to the rule that I mentioned. Likewise, those two angles are also defined as corresponding angles, and they are located between the same parallel lines PQ and TS, and therefore they are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees because those two angles are equal to each other according to the rule that I mentioned. Okay, so in the next step, we define the length of this line segment BN or side BN as X. So what is the length of line segment NC? From the drawing, it is very easy to see that NC equals in total to BC minus BN. Again, NC equals to BC minus BN. NC equals to BC, that is 21, minus BN, that is X according to our definition. So in total, NC equals to 21 minus X. In the next step, I copied this right triangle A and C, A and B in new page, and we implement the Pythagoras theorem on this right triangle, triangle A and B. This is the right triangle A and B, that are coming from the original drawing. This right triangle A and B. In any right triangle, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the slopes of the perpendiculars. In the right triangle ABN, the hypotenuse is AB, therefore the square of the hypotenuse is AB square, and it must be equal to BN square plus AN square. AB is 10, therefore AB square is, okay, we did it later. Here we subtract BN square from this equation. Equation 1, and according to equation 1, we should find out that AN square equals to AB square minus BN square. So AN square is the missing side, so we leave it as it is, and it is equals to AB square. AB is 10, therefore AB square is 10 squared, that is 100, minus BN square. BN is X, therefore BN square is X square. So according to equation 1, we should find out that AN square equals to 100 minus X square. This is according to equation 1. In the next step, I copied this right triangle A and C in a new page, and implemented the Pythagoras theorem in this right triangle A and C. This is the right triangle A and C that I copied from the original drawing. We just right now found out that side NC equals to 21 minus X units in its length. The hypotenuse AC equals to 17 units in its length according to what is given as the equation. So in this right triangle A and C, according to the Pythagoras theorem, AC square equals to AN square plus NC square. Again, AC square equals to NC square plus AN square. Here we subtracted NC square from this equation, and finally found out that according to this equation, equation 2, AN square equals to AC square minus NC square. So AN square, that is the missing side, equals to AC square. AC is 17, therefore AC square is 17 squared, that is 289 minus NC square. NC is 21 minus X, therefore NC square equals to 21 minus X square. So actually, according to equation 2, we found out that AN square equals to 289 minus 21 minus X square. This is according to equation 2, while according to equation 1, we have only found out that AN square equals to 100 minus X square. So here we have two different equations for AN square. Therefore, we created equation 3 that states that AN square according to equation 1 must be equal to AN square according to equation 2. So according to equation 3, AN square according to equation 1 is 100 minus X square, and must be equal to AN square according to equation 2. And AN square according to equation 2 equals to 289 minus 21 minus X square. Here we open the brackets of this expression and found out that according to this equation 3, 100 minus x squared equals to 289, and here we have minus, and inside the brackets we have 21 minus x squared. 21 minus x squared equals to 21 squared, that is 441, plus x squared minus 2 times 21, that is minus 42 times x. So it is minus 42x. So according to equation 3, we should find out that 100 minus x squared equals to 289 minus, inside the brackets we have 441 plus x squared minus 42. Here we open the brackets of this expression and finally found out that 100 minus x squared equals to 289, and after we open the brackets, this expression will be equal to minus 144 minus x squared, and here minus times minus is plus, minus 42x equals to plus 42x. So according to equation 3, we actually found out that 1 minus x squared equals to 289 minus 441 minus x squared plus 42x. Here we have x squared on both sides. We have minus x squared on both sides of this equation, equation 3. So for minus x squared we get cancelled. After cancelled minus x squared, in this side of the equation we left only with 100. In the other side of the equation we have 289 minus 441 plus 42x. So here we added 441 to this equation, equation 3, and found out that according to this equation 3, 100 plus 441 equals to 541. So in this equation, in this side of the equation 3, we left with 441 only. In the other side of the equation, we left with 289 plus 42x. So according to equation 3, we actually found out that 541 equals to 289 plus 42x. Here we subtracted 289 from this equation, equation 3, and found out that according to this equation 3, 541 minus 289 equals to 252. So 252 equals to 42x. Here we divided this equation 3 by 42, and finally found out that according to this equation 3, x equals to 252 over 42, that is 6. So x equals to 6 units in its length. So okay, this is line segment BN, this equals to x, and s equals to 6 units. Yeah, and here this is line segment NC, this equals to 21 minus x, and x is 6, so therefore it is 21 minus 6, that is 15. In the next step, we return to equation 1. According to equation 1, we already found out that an squared equals to 100 minus x squared, and x is 6. Therefore, an squared equals to 100 minus 6 squared, that is 36. So in total, an squared according to equation 1 equals to 100 minus 36, that is 64. So an squared according to this equation 1 equals to 64. We took a root out of this equation and finally found out that an equals to the square root of 64, that is 8. So here, this line segment AN equals to 8 units in its length. Here, AN equals to 8. In the next step, we defined the width of this rectangle PQST, the width QSSB, and the length PQSA. Then we have here those two angles are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other. So if this angle is alpha, then this angle must be also equal to alpha, because those two angles are equal to each other. Likewise, those two angles, they are defined as corresponding angles, and they are located between the same parallel lines PQ and BC, and therefore they are equal to each other. So if this angle is beta, then this angle must be also equal to beta, because they are equal to each other, according to those that I mentioned. So in the next step, we proved that the right big triangle ABC is similar to this small triangle AQP. Right? Those two those two triangles are similar to each other. First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to beta, therefore they are equal to each other. And finally, this angle is the common angle that belongs to both triangles, therefore this angle equals to itself. It's the common angle that belongs to both triangles. So in conclusion, we found out that all the triangles in the big triangle ABC are correspondingly equal to all the triangles in the small triangle APQ, and therefore those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive the following equation 2 is true. Actually, we know that in a similar triangles, the ratio between the heights is equal to the ratio between the sides. I repeat again, in a similar triangles, the ratio between the heights is equal to the ratio between the sides. And therefore, we know that the big triangle ABC is similar to the small triangle APQ according to angle similarity rule, and therefore side AM of the small triangle over side AM, again, the height AM of the small triangle APQ over the height AN of the big triangle ABC must be equal to side PQ of the small triangle over side BC of the big triangle. It again, because of the fact that the big triangle ABC is similar to the small triangle APQ, the following equation is true that AM over AN equals to PQ over BC. AM equals to 8 minus B. AN equals to 8. And is equals to PQ. PQ is 8 according to our definition over BC. BC is 21 units according to what is given as the question. So we shall find out that 8 minus B over 8 equals to A over 21. Here we cross multiply this equation and found out that 8 times A equals to 21 times 8 minus B. So here we divided this equation by 8 and finally found out that A equals, according to equation 1, A equals to 21 over 8 times 8 minus B. Here we open the brackets on this side of this equation 1 and finally found out that 21 over 8 times 8 is 21 and 21 over 8 times minus B equals to minus 21 over 8 times B. This is according to equation 1. Okay. Again, according to equation 1, we actually found out that according to equation 1, we actually found out that A equals to 21 minus 21 over 8 times B. Here we multiply this equation 1 by B. So here A times B is AB. And in the other side of the equation we have 21 times B is 21B. And here we have minus 21 over 8 times B equals to minus 21 over 8 B squared. So according to equation 1, we actually found out that A times B equals to 21B minus 21 over 8 B squared. What is the value of A times B? A is the length of rectangle PQTS and B is the width. So the width, the length times the width is the area of this rectangle PQST. So in this side of the equation we have A times width, it is the area of this rectangle PQST. So the area of the rectangle PQST, that is the area that we are looking for, equals to 21B minus 21 over 8B squared. And our mission is to find out the maximum area of this rectangle PQST. And the area is dependent on the width B, because B is the only missing variable that we have in this side of the equation 1. So B is the independent variable in this function, and the area that is AB is the dependent variable. The area depends on the value of B. By determining the value of B, we determine the area. Again, our mission is to find out the maximum area of this rectangle PQST. Or in other words, our mission is to find out the maximum value that this area function can get. So, what is the value of B? That for that value of B, the area, the A times B will get the maximum value. That is our mission in order to find out the maximum value of the area. we will differentiate this area function and we'll equate the derivative of this function area to 0. In this way, we find out the extreme point, the extreme of the extreme points of this function area. And the extreme point might be minimum extreme point or it might be maximum extreme point. And then we have to verify that the extreme point that we got is not a minimum extreme point but a maximum extreme point. Okay, so first of all we differentiated the area function of this rectangle PQST. So the derivative of this expression equals to d of function 21b minus 21 over 8b squared, that is the area of this rectangle PQST. And we differentiate this function area according to the variable b. According to the variable b, this is the width of this rectangle PQST. So what is the derivative of 21b? The derivative of 21b is 21 because the derivative of b is 1, so therefore in total this expression equals to 21 times 1, that is 21. And what is the derivative of 21 over 8 times b squared? This is equals to 21 over 8, and the derivative of b squared is 2b. So in total the derivative of the expression 21 over 8 times b squared equals to minus 21 over 8 times 2b. And we have to equate the derivative function to 0 in order to find out the extreme points of this area function a times b. So we equated the derivative of this function area to 0. So I found out that according to the equation 2, here we took 21 as a common factor out of those two expressions. So what is left from 21 after we took from it 21 as a common factor? What is left is actually 1. And what is left from this expression minus 21 over 8 times 2b after we took from it 21 as a common factor? What is left is actually minus 2b over 8 and is equals to 0. So actually according to equation 2 we actually found out that 21 times 1 minus 2b over 8 equals to 0. Here we divided this equation 2 by 21. Here 21 over 21 is 1. So 21 we get cancelled and we left only this side of the equation with 1 minus 2b. Here 0 over 21 is 0. So in conclusion, according to this equation 2, we found out that 1 minus 2b over 8 equals to 0. Here we added 2b over 8 to this equation 2 and found out actually that according to this equation 2, 1 equals to 2b over 8. Here we divided both the numerator and the denominator of this expression by 2 and found out that 2b over 2 is b and 8 over 2 is 4. So in total actually found out that according to equation 2, 1 equals to b over 4. Here we multiplied this equation 2 by 4 and finally found out that b equals to 4 units in its length. So b, when b equals to 4, then this function will get an extreme point. That is to say, when the width b of this rectangle PQST equals to 4, then we get extreme point of this function. That is to say, then the area could be at its maximum value or it could be its minimum value. In order to verify that when b equals to 4, the area is its maximum value, I draw the function area of this rectangle PQST. The function area is AB equals to 21b minus 21 over 8b squared. So actually, this is the function area of rectangle PQST. That is to say, the area of rectangle PQST equals to 21b minus 21 over 8b squared. in the y-axis we have the area, and in x-axis we have the value of b, that is the width of this rectangle PQST. And you can definitely see that when the width b in axis, in x-axis we have the b, and you can see that when b equals to 4, then the area is at its maximum value, and therefore when b equals to 4, the area is at its maximum value. That is to say, we actually found out the extreme point that is maximum extreme point and not minimum extreme point, and therefore when b equals to 4, the area of this rectangle PQST will be at its maximum value. You can actually find out what is the area of rectangle PQST by looking at this point, b equals to 4, the area is a little bit more than 40. In order to find out exactly what is the area of this rectangle PQST, we put the value of b equals to 4 inside the function for the area, that is a times b, that is equals to 21b minus 21 over 8 times b squared. And here we have repeat again, the function area of this rectangle PQST equals to a times b. A times b is the area of this rectangle PQST because of the fact that a is the length and b is the width, and the length times the width is the area of any rectangle. So the area of rectangle PQST, that is a times b, equals to 21b minus 21 over 8 times b squared. And we found out that the area will be at its maximum value when b equals to 4, when the width b equals to 4. Therefore we substitute b by 4, and we get the maximum area of this rectangle PQST. So the area equals to 21b, and b is 4, so it is 21 times 4 minus 21 over 8 times b squared. B is 4, therefore b squared is 4 squared, it is 16. So the maximum area of this rectangle PQST equals to 21 times 4 minus 21 over 8 times 16. 21 times 4 is 84, and here we have 16 over 2 is 2, and minus 22 times 2 is minus 42. So in conclusion, we should have found out the maximum area of this rectangle PQST equals to 84 minus 42, that is 42. So the maximum area of this rectangle PQST is equals to 42 square units, and this when the area is equals to 42 square units, then the width of this rectangle B equals to 4, and the length, that is PQ, is equals to 10.5 units. 10.5 units times 4 is equals to 42 square units. So the maximum area of this rectangle PQST is equals to 42 square units. Okay, thank you very much.